Hello friends, in the last video we said if you have a projectile motion and you want to analyze the projectile motion, you have to consider motion in two different directions. So to analyze the projectile motion, you have to write equation of motion along x-axis and equation of motion along the y-axis, and then this becomes very easy to analyze projectile motion. Now in this video, we'll see how we can derive expression for trajectory. So what is trajectory? Trajectory is the path in which projectile moves under the gravitational field. So we want to find equation of motion for this path. This is basically trajectory. Sometime in mathematics this is also called find the locus, in which direction this point is moving. So what are the points for which this object is moving? So let's say I have a projectile and this projectile is thrown with velocity u, initial velocity u, at angle alpha, and I want to find equation for this curve. That is, I want a function in terms of x and y, where x is the coordinate of the projectile at any given point of time and y is the coordinate of projectile at any given point of time t. So basically in equation of trajectory we will not have time, we will simply have x and y. So how will you derive this equation? The idea is again same. First you have to write initial velocity in the x direction. So what is the initial velocity in the x direction? So this is the velocity u. So if you take component of u, then in this direction I will have u cos alpha. So this is simply u cos alpha. What is the velocity in the y direction? Initial velocity. So this will be u sin alpha. So velocity in the y direction, the initial velocity is u sin alpha. What is the acceleration in the x direction? Since there is no force acting in the x direction, acceleration in the x direction is 0. What is the acceleration in the y direction? Now since I have assumed my y-axis is positive in the upward direction and gravity is acting in the downward direction, so my gravity is basically negative acceleration. So I have to use a by e is equals to minus g. So now once I have this, I can basically find equation of trajectory. And if you remember, if a object is moving in one dimension, at that point of time we derived a formula, and that formula is you can calculate distance using this formula. S is equals to ut plus half at square. So in this expression, s is the distance, u is the initial velocity, a is the acceleration, and t is the time. So now what I will do is I will use this expression in the x direction and in the y direction. So if I use this equation in x direction, so let us find equation of trajectory. First I will use this expression for x direction. So what is the distance in the x direction? So what I will do is I will put a subscript sx ux t plus half ax t square. So what is the distance in the x direction? Let's call this distance is x. What is the initial speed in the x direction? U cos alpha. And this is time. What is the acceleration in the x direction? This acceleration is 0. So x is equals to simply u cos alpha times t. So this is my first equation. Now I can again apply the same formula for y direction. So if I apply the same formula for y direction, I can write y is equals to, now this will be okay, let me write something like this. So this will be s by e is equals to u by t plus half a by t square. So what is sy? This is distance in the bidirection, simply by. Uy is nothing but u sine alpha and this times t. What is acceleration in the bidirection? So this is minus z and this is equals to t square. So I have u sine alpha t minus half zt square. So now I know x coordinate and y coordinate of this projectile at any given point of time. Now what we have to find the trajectory equation. So equation will be in terms of x and y. It will not include time. For the time being, we have time in the expression of x. We have time in the expression of y. So we have to remove time. We have to basically consider time elimination. So what we can do is we can calculate time from equation 1. So from equation 1 I can write what is time. So this is equals to x divided by u cos alpha. And now once I have this time, I can plug into second equation. So if I plug into the second equation, I will have u sine alpha t is equals to x divided by u cos alpha and then minus, so this is this term, minus half z and time is x by u cos alpha and this is whole square. So now I can write y is equals to u cancel, so I will have x tan alpha minus half and this is gx square and this divided by u square cos square alpha. So I can also write y is equals to tan alpha, this is a constant, times x minus this is z divided by 2u square cos square alpha, this is another constant and this is multiplied by x square. So this is the equation of trajectory. So this is the equation of trajectory and this term does not include time in the final expression. It only includes x by alpha and initial velocity u. So this is the equation of trajectory. And if you remember in mathematics, if you have a function like this, we call this as a parabola. So I can write tan alpha is a constant. So I can write y is equals to b is a constant and c is basically this term g divided by 2u square cos square alpha, that is another constant and this multiplied by x square. So this is equation of parabola, something like this, y is equals to bx minus cx square. So this is the equation of parabola. So trajectory in this case is parabola. So if you throw a projectile, it is going to follow a parabolic path. The trajectory will be a parabola. In practice also you see many examples of such parabola. For example, the trajectory of bouncing ball. So the trajectory of bouncing ball is basically a parabola. For example, in this case, if you throw a ball, this goes like this, then this goes like this, and then this goes like this, and this continue, and finally it comes to rest. So these are the trajectories. So this is one trajectory for one period of time. This is second trajectory. So second parabola, third parabola, fourth parabola. So these are all successive parabola. So you can see if you drop a ball with some angle. So let's say you are dropping a ball with some angle and you also have some velocity. The path or the trajectory is a parabola. Another example is volcano. So trajectory of molten rock ejected from volcano. So if you have, in this case, these are the molten rocks that is coming. So this is, some is going like this, some is going like this, some is going like this, some is going like this. So they all are basically following parabolic path. Trajectories are nearly parabolic. So there are many situations in which you see parabola or you see projectile that follow parabolic trajectory. So in this video we have seen how we can basically derive equation of trajectory of a parabolic path. The key idea is you have to write equation of motion along the x direction and equation of motion along the y direction, and you have to use kinematical equation S is equals to ut plus half at square, where S is the distance, u is the initial velocity, a is the acceleration and t is the time. Once you have written these two equations, your equation contains a unknown variable time. So you have to eliminate the time from these two equations and then you will get the trajectory equation. And the equation of trajectory in this case is a parabola, and we see in also many situations that follow parabolic trajectory in the daily life. For example, if you throw a ball on a surface with some inclination, it follows a projectile or it follows a parabolic trajectory. Volcano also shows parabolic trajectory. So I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. For the timing, thanks and bye.